to you?
For
some reason, I don't understand that.
I think it's typically given to you. So they'll tell you, like, we want you to do it to this level of significance.
So how does that play into the actual formula? Because like I went through all the problems and we never used it. So
Yeah. So you don't actually put it into the formula. It just helps you to know whether or not you're going to reject the null hypothesis.
so that's kind of like your control then?
Yeah, it's kind of like your standard. Like if it's below the alpha, then you'll reject it. But if it's above it, then you keep it. So it's just saying like you have to have a really, really small number, which means it's very different in order for it to actually reject the null hypothesis.
Okay. Okay. Okay, that makes sense.
Okay. Do either of you guys know if Taylor's gonna
I saw her pop up.
join this?
Okay, so
Okay, let me try calling her. Okay, her phone is turned off, so I don't really know what to do.
do you want to start or wait a few minutes?
We could probably start, and then if she gets on, we can go back and review.
Okay.
Okay.
Okay, so lesson 10?
Yep.
Okay.
Okay. Question 3. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25.
Oh, so you have to plug the 90% into the applet, right, to get the z-score?
Yeah, but that one already, it's 1.65, I think.
Oh, we already have it. Okay.
Mm-hmm.
Okay, what was that? Sorry.
What was what?
What did you just say about the first question?
Again, the 90%, the 0.9 into the applet to get the z-score, right?
Oh, okay. Okay.
1.645, or do we put in 1.65?
I've just been using 1.65.
Okay.
I don't know, I guess if we want to be more accurate, we can put 645 in.
Okay, I'll do that then. The sample mean is, or the mean. Wait, what formula
so
do
we
we
don't
use
have
again? Yeah, sorry, go ahead.
no, so they usually give us the mean for the this one. I don't know what we're doing here.
Yeah, I'm kind of lost. Wait a minute.
Yeah.
What in the world?
Because isn't it the one equation? It's like, oh wait, no, crap.
Like the plus or minus one?
Yeah.
That's what I thought too. Hold on. What is a confidence interval?
Okay, so it says remember the standard deviation of the mean is the standard deviation over the square root of the sample size.
Mm-hmm.
And then, oh, dang it. What are we trying to solve for 90% of the time?
Mm-hmm.
If it was 95, that would make it a lot easier. Because then we could just use the 68-95 rule.
Shoot. Then what do we use?
No, I'm not really sure. Well, actually, if we have, like, if we put it into the normal probability applet, then that tells you how many standard deviations away it is. So you could just multiply the standard deviation divided by the square root of the sample size by that z-score, right? Because that's the number of standard deviations it is away.
Is it?
I'm pretty sure. Because if you just were to click in the middle and you put like a 95 in, it should be 2 standard deviations away. Or pretty close.
So I'll put 0.95. Yeah, that's 2. So 0.9. Okay, so hold on. So 1.645 times 50
Divided by
5. Yeah, 5.
Times 1.645. So you get 16.45.
Mm-hmm.
Does that sound right?
Uh,
I have no idea.
you're just basically adding, you're just moving a decimal over.
Yeah.
Oh, gee.
I'm really confused. I thought that we couldn't calculate it if we didn't have a mean. So skip that one for now.
Yeah, let's come back to that one.
Okay. Which of the following statements is true?
So I'm gonna say, because mu is the mean for the population, right?
Mm-hmm.
And then the x is the sample one.
Mm-hmm.
So then x would be a point estimator because it's just doing 1 point instead of like a range of points, which would be the interval. So B.
So the sample mean is, oh, I see.
The point estimator of the population mean. Okay.
I see what you're talking about. Okay.
Okay. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation sigma equals 113. She collects a simple random sample of n equals 64 and computes x bar equals 526. So what is the point estimate for the true GMAT score?
1.96. Oh, so this is when we do the actual one then, right?
This is when we can compute everything, I think. And so the point estimate is 526.
Yeah, I think so.
What is the margin of error for the 95% confidence interval for the true GMAT score?
So since it's 95, we know that's 2 standard deviations away. But I don't know if that really helps. I just don't completely understand how to do the margin of error.
This is really confusing.
It's the most confusing 2 lessons so far for me. The margin of error is half the width of the confidence interval. It is the distance between the point estimator and one of the bounds of the interval.
Okay. So if they want 95, so I think it's still going to be the same thing where you take 113 and you divide that by the square root of 64, which is 8, and then multiply that by 2, because 95 is 2 standard deviations away.
So we're using that little formula right there?
Yeah, I think. Because what I got from that is 14.125. And that's not like crazy huge for a GMAT score, so I feel like that could be accurate. I'm not sure.
Oh, we can check it, don't we? If we do the plus or minus that formula right there.
Oh yeah. So so if we were to solve for like the z-score type thing.
Mm-hmm. Z-score is 1.96, right?
Yes.
Okay, so 526 minus.
Oops.
0.96 times.
Times 13.
498.315. Plus 553 minus 498.315. $55.37. I don't know if that's right. What am I doing wrong?
Okay, I'm getting 20.25 for the margin of error.
What the heck? What numbers did you get?
You got what?
I got 28.25. Because I was looking at the chapter that we read.
Yeah.
Okay.
And in order to find like the confidence interval, you take the mean minus the margin of error and then plus the margin of error. And for that, they just did, so they were looking at 95%, which is 2 standard deviations away. And they multiplied 2 by the standard deviation divided by the square root of the sample size. So I just took 113 divided by the square root of 64, which is 8. And then I multiplied that by 2.
Oh, so that's just the formula for margin of error then?
Yeah.
Oh, duh. Why did I? Okay.
Because I did. Mine is like really close because I found the lower and upper bounds, and then I took the mean and I found the distance between one of the bounds, and it was 27.685. So like it's really close to that number.
Yeah. The thing that's confusing to me is that, like, with the rules that we learned, like the 95 rule, it says that it's 2 standard deviations away. But when you put 95 in the normal probability applet, it's 1.96. So that would be just enough to like give us different answers.
Right.
So that's the thing that's confusing to me.
Whether or not to multiply by 1.96 or 2?
Yeah. Because if I multiply by 1.96, then I get 27.6.
Like ours.
Yeah.
Okay.
I just don't know if she wants us to use the, like, which rule she wants us to use. So I guess we could put in 27.6 or 0.7 or whatever.
Yeah.
If it's wrong,
And then if we get it wrong, we can redo it.
Yeah,
that's 27.6.
Yeah, 685.
Do you want to do number 3? Isn't it the same thing then?
Yeah, it should be.
But it's by, what is the 90%?
But it's 90 instead. So if you just put 90 or 0.9 into the normal probability applet, it's the 1.645.
1.65? Or
645, but it's about the same.
Okay. So 1.645. 23.236.
I got 16.45. I'm not completely sure.
How did you do that?
I just did the 90%, which gives you 1.645, and then multiplied that by the standard deviation, which is 50, divided by the square root of 25, which is 5, which would give you 10. So it just moves the decimal point.
Oh, I did the
Or-
wrong. I did the wrong numbers.
I was
Wait,
gonna
one more
say, I
time.
don't
So
know.
one more,
So if you,
1.645, and then times
yeah,
50 divided by the square root of 25.
which is 5, yeah. So it's like 1.645 times 10, essentially.
Um,
So basically, we would be putting in 16.450.
Yeah, that's what I put.
Okay.
okay. Yeah.
Okay. Let's hope for the best on those.
Yeah.
Okay.
Okay. Question 7 was the lower limit of this confidence interval. So then you just take the margin of error minus, or 526 minus the margin of error. Is that right?
So yeah, sample mean, yeah. 526 minus 1.96.
Minus 27.685.
27. What do you mean?
That was the margin of error. Or I mean,
That's
if
the
you
answer
did,
that we got for number 6.
yeah.
I thought we're just doing the upper and lower limits for the confidence interval.
Yeah.
We
So
are on number
it's
7.
It's that one formula where where is it? It's the mean, and then the lower limit is minus, right?
It's
Yeah.
minus the
The
margin
mean
of error.
minus the confidence interval thing times the standard deviation divided by the square root of the sample size.
Okay, so
So you can just take the margin of error that we found in question 6 and subtract that from the mean, and then add it to the mean to get the upper limit.
Mm-hmm.
27.45. Oh, I see. 498.55. Okay. So
Right,
what you
so
got? Oh, sorry.
I got 498.315.
I got the same thing. For
Oh,
my margin of error, I got 27.685.
oh, I see. And 498.315. Okay.
Yeah.
Okay.
And upper limit was at 553.685.
Yeah, that's what I got. Okay. So for question 9, what would happen to the width of the confidence interval if Gina increased the sample size? It would decrease, right? I mean,
That's what I was thinking, right?
because then you'll have a bigger number underneath the when you're finding the margin of error,
Mm-hmm.
and then that would make your overall number smaller.
Right.
And it because it's getting closer to the sample or to the overall mean.
Yeah, that's true. It would be getting a lot closer because you have a larger group of people.
Okay.
Okay. Question 10. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? So, same thing?
I think that one would increase it because it would give you a bigger z-score to multiply by.
It's true.
Okay, question 11. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is sigma equals 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the nearest whole number.
Oh, this is when you switch it around, right? Yeah, you have to switch it around to find the sample size. That was
So
what
you
you would.
already know. Sorry, go for it.
Oh, sorry. You'd have to switch it around, so it would be we're looking for the sample size, right?
Yeah.
So it would be n because you're switching it around, so it'd be n equals z times sigma, z-squared times sigma over m, and you take that the square root and you what do you that what is that and you square it. Yeah.
Okay. So
I think that's how you do it.
I'm gonna write this out. Okay, I'm getting 246.
246.
Oh. I got 125. Well, if you're rounding up, it's 126. So I did something wrong.
Wait,
Yeah, I
wait,
might
wait,
have done it
what?
wrong too.
I got 16. Something's wrong. Oh, letter
Okay, what
name.
did you guys do?
Oh no. I put 1.96 times 400 divided by 50, and then I put the 2 over. I can't remember what it's called.
Oh yeah, you have to square it. That's
Oh,
fine.
it's over the whole thing though, isn't it?
Yeah.
Yeah, I think part of the thing is that this thing on the bottom, the square root, that's the sample size, and that's what we're solving for. So what I did is I did 50 is equal to 1.96 times 400 divided by the square root of n, and then solved for n. Does that make sense?
I got 245.86.
Yeah, I got the same thing.
Okay, so 246 then?
Yeah.
About that. Okay, so I used the wrong equation because that was the equation that the dude used when he, hold on. Yeah, when he was trying to find the sample size.
I think you used the right equation. I think
just
you
put
just
I
put,
think I put it wrong. Oh, I think I
yeah,
put
I
the
think you
parentheses
put
in the wrong
the,
place.
Okay.
I'm not sure.
Let's try this again. So for rounding up, it'd be 246?
Yeah.
Okay. Okay.
Okay. Information. The mean salary of actuaries is mean of 100,000, and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance of A equals 0.5, and null hypothesis mean equals 100,000. Alternate hypothesis mean does not equal 100,000. You collect a simple random sample of 36 women's salaries to find if the mean is equal to 111,000. Use this information for the next 3 questions. What is the lower limit of this 95% confidence interval? Are we allowed to put this in like the Excel spreadsheet? Oh, I guess we can't because we don't have the
We don't have the data.
Yeah.
So would we find the margin of error first and then subtract that from the mean?
I think so.
What would we multiply it by? Would we multiply it by 1.96 again? Sorry.
Oh, yeah, I think so. Sorry.
I got 11,998.466667.
Wait, you got what? Sorry.
11,998.466.
For the margin of error?
Yeah.
Yeah, I got the same thing.
Okay.
So then we would just subtract that from 100,000?
Okay.
Right?
I missed the part where what's the equation for the margin of error?
That's the one that's like the standard deviation over the square root of the sample size times the z-score of 95% confidence interval.
So I got 88,001.533.
So I got the same thing.
Okay.
Oh, we're supposed to round to the nearest whole number. So 88,002.
Okay. You're right. Upper limit. Okay.
Okay, sorry, I'm like a step behind. The margin of error was 11998.
Yep.
Are we using the decimal places or are we rounding?
I kept it just so until you get to the final answer because you have to subtract that from 100 or from
Right.
100,000.
Okay.
I got 111,998.
Yeah, I got the same thing.
So do we just keep it that number?
That's what I did, but I don't know. I don't think it rounds up.
Okay. So 4.
Okay, so lower limit is 880012.
Yes.
2. Then oops. And then 111998.
That's all you did.
Okay. Okay. Now question 14.
Is it all of the above?
That's what I put.
Okay.
Oh,
I'll
yeah.
submit it and see how we do. Let's hope for 100.
Have one person. Do you want me to do it or?
I got it.
Okay.
Okay. We missed one question. Oh,
Dang it.
we missed the upper and lower limit one, question 12 and 13.
um, exactly sure what I did.
I don't really know what else to do on that. Except for maybe multiply it by 2 instead of 1.96, but not sure.
Okay. Let's see. So
Why did we get the upper and lower limit questions right before and we use the
1.96.
1.96? Yeah.
Yeah, I have
But
no
this
idea.
won't work.
I have no idea.
You think we rounded wrong?
Maybe, but
I'm gonna try a different equation that they gave us.
maybe we're supposed to subtract it from the mean, like 111,000 instead of 100,000. From like the
Why?
sample mean.
But why?
I don't know. That was just an idea.
I think it's because we used the null hypothesis instead of the 111 hypothesis. Is that what it is? Because the sample means 111,000.
Yeah, that's the only thing I can think of.
That's probably what happened.
Okay, let's try that then.
So before you do that, the other equation that I tried was the one that they gave us to find the confidence interval, which is the mean minus the confidence interval times the standard deviation divided by whatever. When I put that in, it gave me a number that was like close to what we got before. So before we got 88,002, and the equation gave me 87,995.
Okay.
So I don't know. I guess
it's worth a try.
Yeah. Let me do these, and then I'll tell you if that didn't work, and then if not, then we'll do the other number.
Well, I'm doing that margin of error minus the sample mean. Just see if that works.
Okay.
Okay. Okay, I'm gonna submit my answers and see if it works.
Okay.
Nope.
Let me try.
What's the other way?
I'll try. Hold on a second. I'm submitting mine real fast and see if it got it. Oh, it's right.
Sweet.
So we were supposed to use the 111,000?
111.
Mm-hmm.
That is good to know. Okay.
I can just give you the answer right now for both of them.
Okay.
So 99,002 for question 12. And then for 13, it's 122,998.
Okay, 1 second.
Okay.
Okay. Will you repeat those?
Okay, so 12 was 99,002. And question 13 was 122,998.
Okay.
Did you guys get it?
Sorry, I have to put in all the other answers real quick.
Yeah.
Oh, okay.
Okay. Okay.
All right.
Okay, I got it.
Okay. Lesson 11.
Okay. Okay, are you guys both on it?
Group lesson 11.
Yeah.
Hold on. Yep.
Question 3. In previous lessons, we had assumed the population standard deviation was sigma. The population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed? We assume sigma is unknown.
Right.
Yeah.
Okay.
For the next two questions, let the null and alternative hypotheses be null mu equals 8, and alternative mu is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample size of 9 and computes. So the x bar is the sample mean.
The sample mean, yeah.
Sample mean equals 11, and the sample standard deviation is 6. Is sigma known?
No.
No. I don't think so.
Hopefully, all of our questions are like this.
He does.
What is the value of t?
So
Kind of like finding the z-score.
So we can't use the Excel for this because we don't have the.
don't have
No,
the
so I
data.
think it's just like
Very-
finding the z-score, except for instead of using sigma, you use the s.
Okay. Yeah, I think so. What does the sample mean?
11. And then the
Oh,
population mean is 8.
Okay, my mind just blanked. What's the formula?
So it's the sample mean minus the population mean divided by the standard deviation over the square root of the sample size. So it'd be like 11 minus 8 over 6 divided by the square root of 9.
Mm.
6 divided by 3?
Yeah.
1.5?
That's what I got.
Okay. Holy crap.
Okay, hold on. So what?
What are you confused about?
Oh, what numbers I'm putting in? So it's 11. Oh wait, 11 minus 8 divided by.
Divided by
S.
6,
Oh,
which is S,
divided
by the square root of 9.
98 to 92.
Is it letting you copy those numbers, or do you have to type them in?
So what I did is I went to the body temp Excel sheet and just like went down and just copied that little section right there.
Okay.
Wait, you guys got 1.5?
Yeah.
Oh, what did I do wrong then?
What did you do for your equation?
11 minus 8 divided by 6 divided by the square root of 9.
Okay, so you want to make sure that you divide 6 divided by the square root of 9 separate from 11 minus 8. So it should be essentially like, or 11 minus whatever the number was. 11 minus 8 is 3. And then 6 divided by the square root of 9 should be 2. So then you would divide 3 by 2.
Maybe I just put the parentheses wrong again. No, it's parentheses. Okay, I just said the parentheses wrong. I'm sorry, guys. It's been a long day.
I get it. It's all good.
Whoa. Okay. So, are we using the descriptive statistics software first?
Yeah.
Yeah, that's what I did.
I just copied and pasted that little section from the body temp Excel sheet and then just put it in the descriptive statistics.
There's no link to the thing.
It's on the data description, the data sheet, the data files under body temp.
Did you download like the whole thing of data files?
Probably should have. Find it.
Here, I'll send you a link to the place where you can get it on the group chat. Or did you already get it?
Don't worry about it. Just give me 2 seconds. Okay, so what question 6, what is X bar?
What was that?
Question 6 is what is X bar, so what's the sample mean?
So I have 98.220.
Me too.
That's what I got too.
And for standard deviation, I got 0.992.
992? I got 922.
Sorry, I got 922 as well.
Okay. Okay.
I just can't read, apparently. Okay.
What is the t-score? So now we put it in the other Excel file.
Mm-hmm. .6. The sample is 21, right?
Counting 20, but I could be wrong.
Oh, it is? Ooh.
Yeah, I'm getting 20.
It's 20. My bad. That screws me up. Okay, so I got negative 1.843.
Yeah, the same thing.
No, I guess I'm just going by the Excel sheet. The Excel sheet's giving me a different number.
On your Excel sheet, under the null hypothesis, did you put 98.6?
Yeah. But then what do you put for the confidence level?
What?
What did you put anything in the confidence level there?
I didn't change that.
It didn't change that number anyways.
I don't know if it changes the t-value if you change the confidence level.
No, it doesn't. But so I don't know why. My T score is negative 1.742.
That's very strange. But your mean and your standard deviation are the same as what we did? Like 98.220 for the mean and 0.922 for the standard deviation?
98.
Okay.
Negative 1.843.
That's what I got too.
And the p-value is 0.040.
That's what I got.
How did you get that?
It's on this sheet. It's under p-value.
Okay, mine is not getting that, but
So what you need to do is you need to make sure the null hypothesis in the quantitative inference, that sheet, is 98.6, and also the test is less than.
okay, that's my problem. Okay, I'm getting 0.4 now. Are you just putting 0.40?
I'm putting 0.040.
Sorry, yeah.
Okay, so what's the correct decision based on this evidence? Fail to reject the null hypothesis or reject the null hypothesis. And so
Reject?
I think so, but I'm not sure.
What is the
so
The confidence interval is 0.5.
so fail to wait, no, it says right here.
the level of significance is 0.05, isn't it?
Oh yeah, so it is reject.
Yeah, because it's less than 0.05.
Okay. For the next 6 questions, we guys have wait time in minutes between words.
Okay.
Copy. Are you guys on 11?
Yeah.
Okay.
Yeah, I'm trying to profile it.
Okay, so now okay. So the null is 40. That makes a difference. Okay, that makes so much sense. Okay.
Okay, so the p-value is like 0.995?
Yes. Only fail to reject.
Yeah.
Yeah, 12 is fail to reject.
Yep.
Okay.
Okay. Then we're changing it to less than 40. U is less than 40.
Oh, that's all we're changing?
I think so.
Okay.
And the p-value decreases,
It does.
but you still fail to reject the null hypothesis.
So let's decrease.
Okay. What? Question 11. What's the p-value? What did you guys get?
0.995.
How did you get that?
Make sure when you put everything into the quantitative inference procedures, make sure that like the null hypothesis is 40 and that the type of test is
Not equal to.
not equal to, yeah.
But for the next, for number 13, it's going to be less than instead of not equal to.
Mm-hmm.
So I have null hypothesis is 40, and then type of test is not equal to. But the p-value says it's 0.142.
And you put in a new set of data from the baby boom.
Yeah.
Uh, Do you know how to screen share?
Yes, but just give me 1 second. I think that they did be able to do that.
Okay, so let me think.
So let's see. Oh, hold on. Okay. 0.995.
Yay!
Perfect.
So much fun.
I know.
Okay. And so our decision was to, what was it?
To fail to
To
reject.
fail to reject, right?
Mm-hmm.
And then switch it to less than. So decrease,
Yep.
and then we still reject, fail to reject, right?
Yep.
Mm-hmm.
Okay. Is this where you guys are at now?
Yep. So for the confidence interval, I'm getting 23.499 for the lower limit.
Let's see. Okay, so hold on a second. So when you solve for that, the mean minus the margin of error, right?
I didn't solve for it. I just looked on the spreadsheet.
Oh my gosh, are you serious? Okay.
Yeah.
So much. Yeah, 23.499, yeah.
Yeah, I'm too lazy to do all that work. So
Dude, I just forgot about that. That is nice. So it's
Okay.
23.5.
Yes.
Yes, that's what.
Glad you caught that because I did not see that.
56.6 is for the upper limit.
Yep. Okay, I'm submitting it. So,
I'm so
we'll
nervous.
see.
Oh my gosh.
Hopefully this is it. Okay, 100%.
Yay!
Oh,
All done for the whole week, guys.
geez, that's so nice.
Oh my gosh. I'm so happy.
Same. Same. Well, this has been great, guys. I'll post the video tonight.
Thank you.
We'll
No
see you next
problem.
week.
See ya.
See you guys.